Today we're going to talk about properties of exponents and scientific notation. Here's an overview of what we're going to be doing in Chapter 5. It is a fairly short chapter with only 4 sections. Properties of exponents. I will try to give you a little tidbit of why with each explanation, but we have been learning this since Algebra 1, so hopefully this is a review. If you are multiplying with the same base, so like a to the m times a to the n, we add those two exponents together. So 2 squared times 2 to the third, add 2 and 3 together. 2 plus 3 is 5. This is because 2 squared means 2 times 2, and 2 to the third means 2 times 2 times 2. If we multiply 2 2's times 3 2's, we are multiplying 5 2's together, so we have 2 to the 5th. And then we'll go one extra step and enter this into our calculator. 2 to the 5th, you use 2, and then your exponent button looks like a caret, or it says like y to the x or x to the y. 2 raised to the 5th, you should get 32. So if we're multiplying, we add the exponents. If we're dividing, we would then subtract the exponents. X to the 6th divided by x to the 4th. 6 minus 4 is 2, x squared. This is really because x to the 6th means 1, 2, 3, 4, 5, 6. X to the 4th, 1, 2, 3, 4. The 4 x's on the bottom cancel out 4 of the 6 x's on the top, leaving us with 2 x's left on the top. Negative exponents move. They take the reciprocal of whatever you're working with. So a to the negative n becomes 1 over a to the n. Y to the negative 3 becomes 1 over y to the positive 3. And let's just make another example. Say we had 2x squared over y to the negative 4th. So in this first example, if you have a negative exponent on the top, it moves to the bottom. In this example, if you have a negative exponent on the bottom, it's going to move to the top, and this will become 2x squared y to the positive 4. If you remember, negative exponents move. If you see a negative exponent, you have to do something with it. You have to move it to the denominator or from the denominator to the numerator. The last one on this slide is my favorite one because it is super, super simple and it takes crazy complicated things and takes it down to just the number 1. Anything raised to the 0 power is 1. So x to the third minus 4x, that whole thing raised to the 0 equals 1. That's it. It's saying we have 0 factors of that, which means there's nothing. It's just a 1. Okay, here's some more multiplication and division properties. If you have 2 things being multiplied inside the parentheses, or more than 2 things, and you are raising the entire set of parentheses to an exponent, you apply that exponent to both of those things. This is like a to the first times b to the first. You multiply that m times both of those exponents. So 5x to the third becomes 5 to the third times x to the third. This is because 5x to the third means 5x times 5x times 5x. We're multiplying 5 3 times, we're multiplying x 3 times. Okay, one step further. In your calculators, 5 to the third. Yeah. And x to the third. I want you to try this next one on your own. I think you can figure out the next one or two. So try the next 2 rows on your own and then we'll check back. Okay, every property on this page is actually like practically the same property. So if you have something already raised to an exponent and then you're raising it to another exponent, you multiply those exponents together. So y to the third raised to the negative fourth would be y to the negative 12th, because 3 times negative 4 is negative 12. But we cannot leave our answer with negative exponents, so this becomes 1 over y to the 12th. The next one is really the same as the top line. You've got multiple things being multiplied or divided inside the parentheses, so we need to apply that exponent to everything inside the parentheses. This would be x to the third over 2 to the third. We wouldn't want to leave our answer with 2 to the third. That's something we can plug into our calculator. X to the third over 8. This last line is just like the third line. We have x to the negative 2 over 4 to the negative 2. It's how we finish this problem that makes the difference. Can we leave our answer with negative exponents? No. Negative exponents move, so x to the negative 2 is going to move to the bottom, where it will be x to the positive 2. 4 to the negative 2 will move from the bottom to the top, where it will be 4 to the positive 2. And then we can actually evaluate. 4 squared is 16, so our final answer is 16 over x squared. The frustrating thing about this is that there isn't one specific way to get your answer. I can't give you step by step, do this, then do this, then do this. You kind of have to look at what you're given and do something with the properties that you know. This may be helpful. If you're familiar with PEMDAS, if you write PEMDAS with 2 letters per line, it can help you visually remember the properties of exponents. When you see parentheses, you are going to multiply the exponents. So connect P to M with an arrow. When you see parentheses, you will multiply the exponents. When you see multiplication, you will add the exponents. When you see division, you will subtract the exponents. And the E's just kind of hanging out there just because. I tend to use PEMDAS like in that order when I'm dealing with my properties of exponents. So here I see parentheses. We need to apply this exponent of 3 to everything inside the parentheses. So 2 to the third, x to the third, y to the, it's parentheses, so we need to multiply the exponents. 2 times 3 is 6. And then finish your problem by evaluating any numbers that are raised to exponents. 2 to the third is 8, so our final answer is 8x to the third, y to the 6th. On B, the first thing you need to do is deal with those parentheses. So on the top, we've got 14, a to the 5th, b to the 3rd. On the bottom, we have the 7, a to the 2nd, and b to the 2nd. Now, we have 3 things that we're looking at. We're looking at 14 divided by 7. What is 14 divided by 7? 2. Then we have a to the 5th divided by a squared. When we see division, we subtract the exponents. 5 minus 2 is 3. And then b to the 3rd over b squared. 3 minus 2 is 1. The other way you can think of it is these 2 a's are going to cancel out 2 of the 5 on the top, leaving you with 3 left over on the top. These 2 b's are going to cancel out 2 of the 3, leaving you with 1 left over on the top.
If we don't write the 1 for the exponent, is it wrong?
You do not have to write the 1, but you will not be counted wrong if you do write the 1. Okay, this last one. The biggest thing with this last one is that the negative 5 and the x to the 4th are not the same thing. This is negative 5 times x to the 4th. So that exponent of 2 has to go on both of them. So we have negative 5 squared, x to the 8th, because 4 times 2 is 8, over y to the 6th. The second big thing is that when you have negative 5, if you're raising negative 5 to an exponent, you really want to put parentheses around it before you put that in your calculator. Negative 5 squared means negative 5 times negative 5, which is positive 25. So our final answer is positive 25, x to the 8th, over y to the 6th. All right, let's do A, because A is another one of those where I want you to realize that the 2 is not a part of the x. This is 2 times x to the negative 1. So negative exponents have to move. The 2 is not going to move. Only the x to the negative 1 is going to move. So I want you to see that when you have a number in front of letters, the number is not attached to those letters. It's not a part of the letters. It is being multiplied to those letters. At the bottom, let's do C. 3a to the negative 2. That means 3 to the negative 2 times a to the negative 2. And then what about this second set of parentheses? It's just a 1. See how it's raised to the 0? Anything raised to the 0 is 1. The 3 squared needs to go to the bottom. A squared needs to go to the bottom. We don't want to leave a fraction with an empty numerator, so put that 1 on the top. Our final answer is 1 over 9a squared. A and C on your own. Pause the video, try A and C on your own, and then play to check your answers. Okay, I tried to show with my colors what I did. So 12 divided by 4 is simply 3. A to the third divided by a to the negative 2. 3 minus a negative 2 is positive 5. For the b's, negative 4 minus this b on the bottom has a 1. Negative 4 minus 1 is negative 5. So we have b to the negative 5. That one will move to the bottom. Down here, first you have to multiply. Keep in mind that that 3 is separate from the x squared. So you have 3 to the negative third, x to the negative 6th, y to the 9th. You would not leave the tops naked, so you'd have a 1 on top. Scientific notation is all about having one digit and then your decimal point and then however many digits after times 10 to the something. If that exponent is positive, your original number was bigger than 1. If that exponent is negative, your original number was smaller than 1. So here's an example. We want the decimal point to be between the 7 and the 8. To move the decimal point from where it is to after the 7, we would move it 1, 2, 3, 4, 5 times. Because the number started out smaller than 1, we use 10 to the negative 5th. Negative exponents mean the original number was smaller than 1. It was a decimal smaller than 1. In this next one, we want the decimal to be between the 8 and the 3. The decimal is currently at the end, so we have to move 1, 2, 3, 4, 5, 6, 7, 8 times. It's a positive 8 because the original number was larger than 1. So in this next line where we have to fill in a blank, we want the numbers to be 9, 6, 3. Because it says 10 to the negative 6, this is going to be a decimal smaller than 1. So 0 point something, we have to move this decimal 6 times. And then fill in with zeros. So our answer is 0.00000936. When the number is smaller than 1, here's a shortcut. When you move the decimal 1 place, you get in front of the 9. To move it to 6 places, you'd have to move it 5 more times. So there's 5 zeros. There's always 1 fewer 0 than the exponent between the decimal point and your number. Then here, we want the decimal point to be 1.57. 1, 2, 3, 4 places, so times 10 to the 4th.